Hello! Welcome to the Unit 1 review. Welcome to the Unit 1 review. I'm going to do 3 separate videos. One for Unit 1, one for Unit 2, and one for Unit 3. Okay, so there'll be 3 different homework help videos with the reviews. So let's do Unit 1. Unit 1. All right. Thank you, Stitch. So, let me see if I can write below the glare. Aha. So your first one is 2x minus 6, 5x. That's your first problem, and it says simplify. This is purely practice on FOILing and distribution. This is number 1. So you can either, to start, ignore the 2 and FOIL these. So 2-part distribution, and then multiply everything by 2 at the end. Or, like I like to do, you can start by distributing the 2. Okay. Boom. Boom. So, 2 times 2x, 4x. 2 times negative 6 is negative 12. And then we're going to multiply all of that by 5x plus 4. Alright, so step 1 was we just distributed the 2. Make sure if you do it that way, you only distribute it onto the first set of parentheses. Now we're just going to FOIL. So we're going to start with my 4x. So 4x times 5x. 4 times 5 is 20. X times x is x squared. 4x times 4. 4 times 4 is 16 times x. All right, we're done with the 4. Sorry, we're done with the 4x. Move on to your negative 12. Notice the negative sign. Negative 12 times 5x is negative 60x that we get on room. Oh, yeah. And then negative 12 times 4. Negative 12 times 4 is negative 48. Okay. Combine your like terms. So there's no other term with an x squared, so this is just 20x squared. However, these both have 1x, so I can combine these together. Remember, think of this in terms of whatever you want. We'll do pineapples. No. We are negative, it's easy to think of money. Okay. So let's say I have $16 in my bank account. That's rather sad. I have $16 in my bank account, and I spend $60 using my credit card. Uh-oh, now I owe money. Now I'm at negative 44. Now I owe my bank $44. Okay, so you can combine those together. And then minus 48. And that is how you would leave your answer. Okay, that's number 1. Okie dokie, here's number 2. So this one, there's no number in front, so you don't have to distribute. You're just going to FOIL, which is our 2-part distribution. So I'm going to start with my negative 3x. All right, so negative 3x times negative 2x. Negative 3 times negative 2 is positive 6. X times x is x squared. Negative 3x times 5, negative 15x. And we're done with the negative 3x. So move on to your 2. 2 times negative 2x, negative 4x, and then 2 times 5 is 10. All right? Do not stop here. here. I will not give you full credit. I won't. So, combine your like terms. I can't combine anything with 6x squared, so rewrite it, 6x squared. And then negative 15 minus 4x. Negative 15x minus 4x, negative 19x. And then there's nothing I can combine with 10, so just rewrite it. Plus 10. So that is number 2. All right, number 3. It says, hold on. Given the equation f of x equals x squared plus 6x minus 10, find the following. And then you have a, b, c, and d. So the first one is f of 0. Notice the 0 is where the x is. So you're substituting 0 in for x. So this is going to be 0 squared plus 6 times 0 minus 10. All right, you substitute 0 in for x. That's 0. 6 times 0 is also 0, minus 10. So you get f of 0 equals negative 10. Okay, so that's how you do A. Make sure you try B, C, and D first by yourself before you come to me. All right, so try the other ones by yourself. You can pause me. Did you pause me? Did you? Don't lie to me and stitch. Okay, so B is negative 3. Yeah, nope. Positive 3. Nope. Yes. B is f of 3. So this time you're going to substitute 3 in for x. So 3 squared plus 6 times 3 minus 10. Okay. 3 squared is 3 times 3, which is 9, plus 6 times 3, which is 18, minus 10. And then just combine all these together, right? So 9 plus 18 is 27, minus 10, 17. So when x is 3, f of x is 17. So that's your answer for B. Sweet. All right, here is C, f of negative 2. So I'm going to substitute negative 2 in for x. Negative 2 squared plus 6 times negative 2 minus 10. Well, I started to get a little lopsided there, my bad. So then solve. Negative 2 squared. Negative 2 times negative 2 is positive 4. 6 times negative 2 is negative 12. And minus 10. Okay. Combine them all together. Okay. Woo. 4 minus 12 is negative 8. Minus 10. Negative 18. So when x equals negative 2, y equals negative 18. One more. All right, the last one for number 3 is D, f of 1. So I'm substituting 1 in for x. So that would be 1 squared plus 6 times 1 minus 10. Here we go. 1 times 1 is 1. 6 times 1 is 6 minus 10. Combine them all together. 1 plus 6 is 7 minus 10. 7 minus 10 is negative 3. So when x equals 1, f of x equals negative 3. Number 4 says, given the table, write an explicit equation. An explicit equation. So not a recursive. Okay? We won't have any recursives on the final. So when you're asked to write an equation for a table, your first step should be to figure out what kind of equation am I writing. Is this linear, exponential, or quadratic? Right. The way to figure that out is by the rate of change. So what is the rate of change for this table? What am I increasing by each time? Five. 8 plus 5 is 13. 13 plus 5 is 18, and 18 plus 5 is 23. So you are increasing, and your x's are just going up by 1. So your x's are just going up by 1. So if you're adding or subtracting the same thing each time, it's linear. So linear should bring this into your brain. All right, slope-intercept form. Y equals mx plus b. Where m is the slope. So the slope is change in y over change in x. So that your change in y is 5. Your change in x is just 1. Okay. 5 over 1, which is just 5. So I have 5x. Oh, not plus yet. B is your y-intercept. B is your y-intercept. I don't have my y-intercept in the table. Couple ways you can figure it out. For me, I like to do the pattern backwards. So my y-intercept is when x equals 0. So if x is equal to 0, what would go here? What would fit our pattern? Three. So you could do the pattern backwards, so it would be 8 minus 5, because this fits our pattern of adding 5 each time. So you have 5x plus 3. That is your equation. Okay? What else? Another way you could do it, if you don't want to do it that way, is say, okay, my slope, I knew my slope was 5. I knew my slope was 5. Let me get rid of this for a second. So I'm going to multiply my x value by my slope. And then what else do I need to do? So my slope is 5. So 1 times 5 is 5, but it needs to be 8. So I need to add 3. 2 times 5 is 10. 2 times 5 is 10, but it needs to be 13. So once again, I need to add 3. 3 times 5 is 15, but it needs to be 18. So once again, I need to add 3. So that's another way you could figure it out. Right? That way, yeah, that will also always work. So that's your answer for number 4. I think that's all it asked for. Yes. So these are not exact, okay? But for number 5, you have 3 graphs, and you have to say which one is a function and why. When you're given graphs and you have to determine if they're a function or not, you can use the vertical line test. So I wonder if this should be too thick. No, that's fine. So, vertical line test. If it hits your graph at more than 1 point, it's not a function. So it's hitting it twice. So this one is not going to be a function. You could also draw vertical lines through it. Okay. And it hits here and here. That means when x is, whatever this is, let's say it's -2. When x is -2, it has 2 y values. That's not allowed. That's not a function. To be a function, every x value can only have 1 y value. Every x value can only have 1 y value. So let's go to our next one. Vertical line test. It hits it more than once, so it is not a function. Last one. Vertical line test. It only hits it once. It only hits it once. Okay, I could move my ruler across, and it would only hit 1 point at a time. So the third one is a function. Every x value only has 1 y value. Every x value only has one y value, and it passes the vertical line test. Okay, here is number 6. You have to write the domain and range of the graph. Write it in interval notation. So, once again, I sketched it, so don't expect it to be to scale. So domain, where can we do this? We'll do it here. Domain is your x values. So you're looking from left to right. So, yeah, that was right. My graph is continuing on forever in this direction. Going on forever and ever and ever and ever and ever. So my domain, this is negative x values. So this is like -3, maybe, -5, and it goes on forever in the negative x direction. So your domain, with a parenthesis, negative infinity, parenthesis, because we never get there. We never get to negative infinity because it's infinite. You never actually get there. So use a parenthesis. What about if I look from left to right? So here we go. It does not go past 3. So your domain is negative infinity to 3. It does not go any further in this direction. And 3 is on the graph, so you use a bracket. That is your domain. Range. Range, you're talking about what? About y values, sorry. So, your graph is continuing forever, and it's going to gradually decrease. So it's continuing forever in, actually, that's probably not true. Oh yeah, I just didn't draw mine very well. Okay, so our range is going to be negative infinity to positive infinity. It's going to continue forever in the positive and negative directions. Okay, so that's number 6. Whew, that is it for Unit 1. Boom. That wasn't so bad. Wait, actually I want to show you one thing before I end this. Let's say that this was a hole. Let's say there was a hole there, okay? That doesn't affect your range at all. Your range is still going forever negative and forever positive, but it'll change your domain. If you have a hole, then that means we're approaching x equals 3, but we never actually hit it. We're approaching x equals 3, but we never hit it. So this would have to be a parenthesis. Okay? If that was a hole, then this would be a parenthesis as well. But it's not, it's filled in. So that's why it's a bracket. Okay, now I'm done.